too much energy, then we're having too much in diet cost. If we don't have enough, we're reducing the bird of what it's actually intending. So if we're intending to supply 3,050 kcals per kilogram in a diet, much less than that, certainly it's going to have implications on feed conversion and so forth.
Welcome to the Feed Science Podcast. My name's Adam Fairknowles, coming from North Carolina State University's Animal Food Manufacturing Program, and on behalf of WiseNetics, thanks for joining us today. Our guest today is Dr. Bill Dozier. Dr. Dozier is a professor and extension specialist at the University of Auburn in the Poultry Science Department. Dr. Dozier, how are you doing today?
Doing great.
Excellent. If you wouldn't mind, introduce yourself to our audience, give a bit of your background and what you're working on these days.
My background has primarily been in poultry nutrition. I completed my master's degree at the University of Kentucky in swine nutrition, and then moved over back down to Auburn University, where I got my BS degree, and completed a PhD in poultry nutrition under Dr. Ed Moran, and both of my advanced degrees were in amino acid nutrition. And from that, upon graduation from Auburn, accepted a job as extension specialist at the University of Georgia. Was there for approximately 3.5 years, and then moved over to USDA ARS in Starkville, Mississippi for about 5 years, and then moved back to Auburn in a research teaching role in poultry nutrition from 2008 to 2019, and then in 2019 I accepted to serve as a department head, and then in 2024 I stepped down officially as a department head and assumed an extension specialist role. So currently I've got a 75% extension and 25% research. So
very good. So a lot of different roles within kind of the academic and research side, and a lot of interaction with the industry through all of the extension and USDA work. My first interaction actually with Dr. Dozier was when I was a graduate student, and you would have been at Mississippi State working with ARS. We did some of the very first work that got done on the what happens if you feed like coarse particle corn and blend it with pellets and whatnot. And we made all that feed at Kansas State University. It was a research project that was part of the dissertation of Patrick Clark, and made a lot of that feed. And then myself and a couple others drove that down in the back of a Penske truck all the way to Mississippi. We thought that was a good idea, so that's what we did. Drove down Mississippi, dropped it off, and drove back to Manhattan. So had some collaborative work. I mean, that's got to be 2006, 2007, somewhere right in there. So
2006 and 2007, yeah.
So that was some of the first work that had really, I think, started to really dip into this idea of, what the particle size actually needs to be for chickens. And we had probably gone a little too far into grinding for pellet quality and things like that, and forgot the bird has a gizzard. And we've reversed quite a bit of that. And I think that's where some of that work started. So kind of neat to have been involved in that from the jump. I know a lot of what we had talked about previously as far as discussion today was actually talking about kind of in a similar way, things that interact between the feed milling side of things and nutrition. And one of the topics we discussed was energy variability, and the fact that all these different feedstuffs that we have, whether it be across feedstuffs or among individual ingredients, there can be a lot of variability in those ingredients as they come in, and the proper process of receiving and sampling and sending samples off for analysis at the mill, and then how that can eventually impact the nutrition of the animals, of something that we may not consider as much as we should. So I know you guys have done some work and stuff in that area. So I think that's going to be the source of our discussion. So I'll let you take it from there. And what are some of the things that we need to think about when we think about what kind of variability we see in these ingredients that we're using for energy in the bird?
Yeah, I like to just start out just from a basic standpoint. If we were kind of really looking at a just from a mathematical standpoint, if we considered a diet that maybe a little high on energy, say in this example, say 32-60, where we had 70% corn, uh, roughly 24% soy, 2% fat, and 4% say some crystalline amino acids. In a diet like that, AME corn would represent about 71% of that in this mathematical exercise, academic exercise, say. And soybean meal, about roughly 16%. So the 24% soybean meal inclusion would be, estimated at 16%, whereas 2% of, say, soy oil, poultry fat, something like that would be at 6%, would be worth about 6% AME in this kind of exercise. So, and then, then you've got to consider your crystalline amino acids. They actually have some energy value as well. But I think it's very important to really think about this variability and what it does on bird performance as we're entering into this new crop corn. I think that's something that's very pertinent and relevant today. Is really thinking about variability from crop years. I think that's extremely important. I was looking back over, like I guess last spring, at some data from IFF and looking at from a yearly standpoint. And so from 2020 to 2023, certainly there's a spread there in terms of AME on kcals per kilogram, roughly about 70. So, this certainly can be impacted by crude protein. Moistures, we know we will be seeing some variability there. Can in moisture throughout the year. I mean, early on it'll be much higher, and then as we get toward the spring, we'll see much latter contents, lower contents, and then as well as oil in corn samples. So, I think as a good exercise to do that, if you're noticing that within a particular new year, say in 2024, that the overall crude protein or moisture content, as well as fat, may be a little different than you've experienced in the past, that you can take a relatively large sample size of corn with some of these um, metrics, and particularly with NIR, you can develop some regression equations. Something really simple as, just looking at moisture and looking at terms of percent fat in terms of corn, and develop some equations and really use that to adjust upward or downward in terms of AME of corn, because that ultimately can impact feed conversion, because currently right now new crop corn, we know that we've seen this in the past, that high moisture corn certainly can dilute nutrients and have an impact on FCR. So I just would want to encourage everyone to just really take a look and at some of these corn samples and get a good develop an appreciation of the overall, variability. In 2023, over like 650 samples, it was estimated that the maximum content would, range around 3,700 and go all the way down to 3,000, with an overall value of about 33.49. So it's very similar to what we would anticipate, formulating for, typically on that average value, but you do have relatively, good spread in terms of AME. Crude protein averaged, I believe, in these samples about 7.25, but quite a bit of spread in crude protein. Moisture content about 14.1, so you'll have some spread there in moisture, and then fat about 3.5%. But in all of these variables, you're going to see with a lot of samples, you will see variability. So if you're seeing more or less, hey, it's worth really taking a deeper dive and really understanding that. And you can do that through a simple prediction equation. Because when we take a look at corn, Adam, and really look at the energy value, you know, we talk about carbohydrates represent about 75% of that, and amylopectin and amylose represents about 60% of that 75%. So, certainly starch value has a big impact on AME. So, really think from a corn standpoint, it's just really understanding this and what the total AME has on bird performance.
I want to ask them about the bird performance. Some of our audience will be familiar with poultry nutrition and others less so. But before we do that, when we think about, you're talking about like all the samples that are pulled, and when we think about why sampling and why analysis is important, and certainly for the part of our audience that is maybe more in the mill, this is really good information for them to understand. Yeah, this is why we have you sample, this is why we have you test. I'm wondering, from the how do you make a decision if you are, let's say, the nutritionist in this situation, and you're seeing all these samples come in? How do you make a decision on when you will actually update your matrix, when you will actually make a change to the formulation? How is that? Is that a matter of preference? Some are a little more risk averse, others are less risk averse. Some are just constantly updating, or is there a scientific approach to that where we say, okay, this is how we would decide when it's time to make a change?
That's a good question. I think a lot of it's just preference, and particularly if you get, to me, seasonality changes are really big when you are starting to see like a new crop coming in, and really taking a look at that and getting a handle on the amount of variability you're seeing. But there's not really I don't really see a scientific way. It's just trying to get a better understanding or appreciation of ingredient variability, because to me that's very important. I mean, a lot of our diets are all formulated somewhat very similarly, but the big difference to me is ingredient variability, and it's just something we've just got to monitor.
Well, I guess there's two sides to it. There's a cost side, and then there's also, of course, the bird performance side. So what are the actual risks? You threw out, feed efficiency there earlier. What are the risks, either to the bottom line or to the bird growth, which obviously those things are going to correlate together. But what is the risk when we don't do a good job actually tracking this energy, and what are the risks of we're feeding too much energy, and what are the risks of we're feeding too little energy if we're not actually watching this variability as it occurs?
Right. So, too much energy, then we're just having too much in diet costs. If we don't have enough, then we're reducing the bird of what it's actually intending. So if we're intending to supply 3,050 kcals per kilogram in a diet, we're much less than that. Certainly, it's going to have implications on feed conversion and so forth, which can have depends on how big your operation is, how big your birds are, so forth. You start really looking at what a point of feed conversion is worth on some of these complexes. Those numbers can do the extrapolation. They can get extremely large.
Yeah, yeah. it's been told to me, and this is usually coming back, to the feed milling side of this is why we have to make sure we get, all the moisture out after pelleting and cooling, and why it's important to sample the ingredients. And, some of these, like you said, really, really large complexes, point of feed conversion and millions of dollars kind of a thing. Those numbers get pretty big, pretty quick. So it doesn't take long. Again, my guest today is Dr. Bill Dozier. Dr. Dozier is a professor and extension specialist in the Department of Poultry Science at Auburn. What about some of the other ingredients? Most of the time, we're going to chase energy with the carbohydrates, cereal grains we're using, and then we're going to supplement that as we need to, usually with a fat source, in order to get the energy where we need. And depending on the price of fat and depending on the price of corn, we'll use more, we'll use less. What about variability in our fat sources? I'm guessing, well, I know to be the case, some are going to be more likely to be variable than others. What are some of the things we have to do on that side of things in order to make sure that, we're not just watching our carbohydrate source, but wherever we're getting our supplemental energy from as well, that we're doing that appropriately?
Over the last several years, I've been looking at fat sources. We've looked at distillers corn oil. We use soy oil as a reference. We've looked at some acidulated products, both from soybean oil as well as palm oil. Recently, I've been looking at some fractionated palm oil. And, the first thing that always comes up in a conversation, we're talking about energy and fats and so forth, oils, is oxidation, and that's the big question. And to our surprise, we looked at some distillers corn oil, but back sources several years ago at roughly 5, 10, and 15% free fatty acids, and really to our surprise, we didn't see that big of a reduction of even at 15% free fatty acids. So I think that it's very important for us, I think, moving forward in the future to understand what is actually the composition on those free fatty acids that we see in these different sources, because I really think that can have a different impact. Because we go back and look at Dr. Weissman's data on free fatty acids and ratios to unsaturated to saturated on both young pigs and chicks. There's certainly some differences, and he created an equation, but I think now we're certainly need to refine some of that, I think, even further, and just gain a better understanding, because we look at initial peroxides. So peroxides is starting that oxidation process, but also we've got to take a look at aldehydes. And we've seen that with some of the work that's been done out of Iowa State with Brian Kerr's lab up in Iowa State, that we can see on peroxide and aldehyde values that we can drop, overall weight gain to, I'd say, 2.5 to 5%. So I think that's something that we need to look at, keep at home, but certainly that as we add some of these antioxidants that can help, certainly reduce some of that oxidation effect. I do think that when we look at some of our acidulated products, and we see very large free fatty acid numbers ranging, say, from 35 to 60% free fatty acids. The first thought is that it's an oxidation effect going on, but really you can get into feedstuffs like these oils, that it's the overall acidulated process that are creating these free fatty acids. As we're adding sulfuric acid to this, it's creating this, because we noticed that we just had a sample that was sent off recently that had roughly 55% free fatty acids in a acidulated soy oil product, I believe. And in terms of what we saw with initial peroxides and adenosine values, I mean, they were very, very low. So I think it's important to keep that in mind too, as we see with this way these renewable energy is moving in the future, and where some of these oils are going to go in terms of inputs. And with that, certainly we may be looking and trying to identify some alternative sources. So I think it's very important for us to really understand about free fatty acids, or oxidation, initial peroxide values versus our aldehydes, and where that is in some of these sources.
Absolutely. Yeah. Like you said, I mean, it's there's huge questions on like how much soybean oil will be available. Could be plenty, or if it all goes, the way of biodiesel, then we're going to be looking somewhere else, for plant sources anyway of oil. And you can make some of these bioproducts out of other fat sources as well. One last thing I wanted to cover on this before we kind of close out our conversation, in your experience, as you've spent time with industry and stuff in an extension role, what does the actual like push pull look like for, it's going to be geographic, it's going to be the desire of the nutritionist, it's going to be what the people in purchasing can do on something like a fat, of what we can actually get. I mean, we can get anything if we're willing to pay it to ship it, kind of thing, but there's going to be certain geographic limitations, and then there's going to be the kind of fat that I want, right, based on some of these things you said. And so I'm curious, in your experience, as you've watched people work through this in the industry, how much is this is what you're going to have access to. Now you need to understand what's in it, and how much of it is, hey, I know what I want my fat to have in it, so this is what I actually want to buy. Which one of those tends to control what we're actually getting to put into feed more than the other?
Well, I think you hit on a very pertinent topic, and that is, it gets down to communication. And the nutritionist needs to have a really great relationship with the ingredient buyer, so they're all on the same page, because I've seen this repeat itself in that the ingredient buyer can get a great purchase on a product, and nutritionist puts it in the feed, and then we see increase in FCR, and even though at the time it may be a great deal or great price on this product, it's really not the most economical, because it's impacting bird performance. So I think it's very important for those two people to have a clear understanding of what are the specifications on a certain ingredient, and what are you actually looking to purchase.
Yeah, I think it's going back to kind of what we started with. Obviously talking about corn, but fat sources and anything, or any ingredient really, it all applies the same. Where, yes, once it arrives at the feed mill, we want to sample it to know what we got, but we're also now going to feed that's what we are going to feed.
Yeah.
And chances of, other than some of the really basic stuff that we can do, for example, with NIR, chances of us having all of the information back in time that we can then use it to formulate the diet, some of us is going to be after the fact. So that's why I agree with you completely. That idea of communication of, yes, I'll sample it when it gets here, but I need to know what I'm getting before it ever gets here. And this is what I want, because otherwise I'm behind the eight ball the whole time trying to chase it. And what I'm sampling and what I'm testing and the results I'm getting back is the stuff that was there, a week and a half ago, and it's long since gone. And now I'm doing it again, and I'm formulating off of the next thing. And if I don't have a better handle on my variability before it even shows up because of that lack of communication, we're constantly going to be chasing it.
That is true.
It's time for our famous three.
Okay. I do want to close out with one last. one last question, because of the role that you've played for a while here with in between kind of academia and industry on the research and extension side. And I haven't gotten to ask this particular question to folks. It's a little different than our nutrition discussion, but you've been in a role with extension and research where a lot of your career has been trying to take information and disseminate it out to the industry such that it will be useful for them to improve operations, performance, all that other kind of stuff. What have you found that has both worked well and hasn't worked very well on actually getting that out? I mean, we know we're all told in the academic circles, you have to publish and you've got to get into the papers and into the journals, which is certainly true. But we also know that, not everybody out in the industry is sitting down and reading all the journals all the time. Open access has probably helped with some of that. So, so that's one method. And it's not that it's a bad method, but what else has worked well? And then what are some of the things that, maybe you thought would work well, or others had said, hey, this should work well, that has turned out, yeah, that wasn't really worth the effort because that was something that helped me actually get that information out to those folks.
Yeah, I think on an information standpoint, I mean, I I still like the one-on-one interaction. I think that's extremely beneficial. But in terms of mass, reaching a large group of people, I really like the popular press as opposed to the journal. I know that the, from an academic standpoint, that's very important. But at the same token, we've got to repackage this in such a way, whether it's in a newsletter or at an industry meeting, we're giving a presentation and putting it into layman's terms on how it will really fit in an operation. The other side of this is sometimes we do research and it seems to work well at the university, but
Hmm.
just from a logistics standpoint, I think that's very important for us in academia to understand that how is this really going to fit in a day-to-day operation. And I think that's extremely important too. And everyone has a lot of different, every situation's different from one complex to the next, whether it's bin space, whether what their housing differences are, and so forth, and logistics and driving, moving it from the mill to to the farm and so forth. So
I think that it kind of goes back to the communication side, right? The idea of the folks doing the research, and honestly, we usually think about that academic, but plenty of the companies we work with have their own research arms and things as well, and they have their own farms and facilities and that sort of stuff. And there's a lot of communication that needs to go on there with both sides understanding the other, I think, where we need to be able to communicate, well, here's how we have to do it in an academic environment because of the constraints we have, the way we have to set up an experiment, the size of the experiment we can handle, what we have to be able to do in order to publish it, all of that. And we need to make sure that we can explain to our industry partners, our stakeholders, that there's a reason we've had to do it that way, while also then get them to understand that if they do not. But also, as you said, not just living inside of our own research operations and being able to take that information and say, now, yes, what happened over here in the research barn where we were feeding the animals by hand and checking on them, 3 times a day and everything, we understand that that can't happen in the industry. So here's what we think would happen there. And getting kind of both sides to spend at least a little time understanding how the other side works, I think becomes really, really important. If you don't, everybody kind of thinks that what the other side is doing is impractical and they don't understand what's really going on.
what I meant by repackaging it and being able to
Yeah.
put it in a format that's going to work to translating it out into the field. So
Yep, I think that that's something that we we all probably can kind of continue to develop. And again, that's both sides of the coin there, where the folks in the field need to understand the way that research is being done, and the researchers need to really understand what's not practical once you go out and into the field. And that doesn't mean that, that you don't do the research the way that it needs to be done. It just means you have to understand what will translate and what may or may not. So
a lot of times we have treatments that, for the sake from the academic side to enable to get it published, may not be applicable in certain situations out in the field.
and then being able to explain why we did it. So someone doesn't read that work and go, well, that doesn't make any sense. And to be able to say, no, I knew it wouldn't make sense in the field, but in order to get a wide enough response curve, I had to go above and beyond what you would ever do. But no, it wasn't because I thought that was practical. It was because I needed to get that data point to make the data work, kind of a thing. And being able to explain yourself that way, I think, is really important.
I think it's important from a researcher side to really gain an appreciation of nutrient levels and ingredients to finished feed. So we truly understand exactly what was fed to these birds.
Yeah, very much so.
That way there's no gap in communication.
I agree. Well, it's been a great conversation. Bill, I really appreciate your time today. Thanks for joining me.
Yep, I enjoyed it.
You bet. My guest today has been Dr. Bill Dozier. Dr. Dozier is a professor and extension specialist at Auburn University in the Department of Poultry Science. Once again, for the Feed Science Podcast and on behalf of Wisenetics, I'm Adam Fahrenholz, coming to you from North Carolina State University. Thanks for listening, and we'll talk to you the next time.